Hi everyone, and welcome to this Telium webinar. Today we'll be talking about Telium plus Amazon Web Services, and we'll be focused on serverless real-time PII detection. So this is part one of two. My name is Michael Liro, and I'm a product manager here at Telium. Today I'll be introducing an architectural pattern for identifying and managing PII within a high throughput data system. So this architecture focuses on a couple of main areas. One, serverless, so using an architecture built on managed services that abstracts away infrastructure management. It's cost effective and also operationally agile. Two, real time. So we have strict performance requirements, right? It's crucial for this use case that demand immediate action based on the incoming data. And three, AI excellence. So our ultimate goal of implementing data governance not as an inhibitor, but as an enabler of advanced AI and ML applications that rely on high quality, trusted data, right? So overall, the architecture that I'll be presenting here is more than just a solution for PII detection. It is powerful and reusable design pattern. So the pattern is a blueprint for applying computationally expensive or high latency processes to high volume real time data streams in a cost effective and scalable manner. So the core principle of this is a cheap, fast, and potentially less accurate initial check from an expensive, slower, but highly accurate secondary verification. So in part one, we'll cover this initial check in Telium, right? And will act as a high volume filter, ensuring that the vast majority of events which don't meet the initial criteria are never going to the next stage, right? So this will dramatically reduce the number of invocations of the expensive process, which we'll cover in part two. So when we implement this design pattern of two-stage validation, right, we're helping to minimize both monetary costs and overall system latency. Now let's jump into the agenda to see what we're going to cover. So first, we're going to talk about the data challenge and the Telium solution. Then we'll define real-time in Telium terms. We'll prime the pump by reviewing important terms and information about what we'll configure. And then we'll get into step one of configuring the real-time PII, focusing on email detection configuration. So first and foremost, the challenge. So data compliance and security. We live in a world where things are constantly changing and information is still being regulated. So identifying and managing PII within a high throughput data stream is a challenge. Most companies are doing this in batch. So we also, when doing this in real time, need to tackle that operational cost and complexity, right? It can't be too expensive. It can't inhibit what we do as a business, and we don't want to take on a lot of tech debt, right? So this implementation of data governance needs to be an enabler, not an inhibitor, right, to our overall goals around AI, ML, and our business. So the Telium solution solves these challenges by architecting an intelligent real-time pipeline that uses the cost-effective multi-stage validation process that we spoke about a few slides ago. So this architecture allows us to identify, verify, and govern sensitive information like PII as it's collected, right? Ensuring the data is compliant and secure. So the Telium platform ensures data is governed and trusted, high quality, understandable, and available in real time. These are four key aspects of how Telium fulfills this foundational requirement for compliance and AI. So let's take a look at these foundational requirements a little deeper. So the success or failure of AI initiatives is directly predicated on characteristics of input data. So the four pillars of AI-ready data are obviously all around data. The data must be high quality, governed, understandable, and available, right? So high quality, this is where we're addressing data integrity, right? Accuracy, completeness, consistency, governed. So, right, it needs to be auditable, right? And we need to have data security. So the ability to enforce user consent, to filter, hash, redact sensitive information like PII or PHI, right? And maintain a complete immutable audit trail for regulatory and oversight purposes. So in a modern data ecosystem like Telium, this is a non-negotiable functional requirement. Third, it needs to be understandable. So consistently labeled, right? Well defined, contains rich contextual attributes that allow a model to differentiate meaningful signals from random noise. So without this, data is merely a collection of values, right? With it, it becomes information. And the data needs to be available. So this speaks to both interoperability and latency. So the data needs to be programmatically accessible to a wide range of downstream systems, from data warehouses, marketing platforms, AI and ML tools, right? And this typically happens via API webhooks or other standard integration patterns, right? And furthermore, the data must be delivered within a time frame that allows for meaningful action to be taken, right? This is the essence of the real-time system. So now that we've defined these challenges and proposed solutions, let's cover some important foundational terms and definitions, right? And the first one of those is talking about real time. So the concept of real time is often used ambiguously. Teal time is real time, and that corresponds to a sub 300 millisecond processing latency. So moreover, the sub 300 millisecond processing latency is vital to AI and ML models' decisions, right? Whether to personalize the user experience, flag a potentially fraudulent transaction, identify a PII, identify a compliance risk, right? These hold maximum value only if it can be acted upon while the context is still relevant, which often means during the current user's interaction. So Telium's sub 300 millisecond data pipeline makes that possible. So let's jump now into priming the pump, right? Let's talk about what we're going to talk about. First and foremost, right, we're going to cover how the Telium platform organizes data into a distinct hierarchy of scopes and what scope is required for different AI and ML activities. And we'll cover the different types of functions, right, those serverless environments that we provide and when to use them. And then in part two, we'll dig deeper into the AWS portion of this, where we're using AWS Comprehend to identify PII at the end of the pipeline. But first and foremost, let's talk about scope. So to build an effective AI and ML solution, right, it's essential to provide them with data that possesses the appropriate level of context for the task at hand. The Telium platform organizes data into a distinct hierarchy of 4 scopes. So we have event, visit, visitor, and audience. Today, we're focused on event, but we will cover these just so you have that context. So this is more than just a data model. It's a conceptual framework for understanding and reasoning about behavior at different levels of resolution and aggregation. So first and foremost, let's jump into event. So the event scope, right, this is the most granular atomic level of data, representing single interaction captured in real time typically, or it can come from a file upload or API, right? So examples of this might be a page view, a button click, a purchase event, a check-in, a checkout, right? So for AI applications, event level data is ideal for stateless in-the-moment analysis, right? Detecting anomalies in event patterns such as that or triggering immediate automations. So this is the scope of data that we will be focused on and working with today. Next is the visit scope. So this scope represents an aggregation of events into a single session or visit, right? It provides stateful information that captures typically a user's journey within a specific interaction period, right? And on the web, this might be 30 minutes. On the mobile, it might be 5, right? Session depends on device typically. This will include information such as, the number of pages viewed during the visit or the sequence of searches performed, right? All of that rich information. So this session level context is critical for AI models that analyze the user's short-term intent. And examples of this are predicting session level outcomes like cart abandonment, right? Identifying points of friction in a customer journey. Now we're going to move into the third, which is the visitor scope. So this is where the platform's real-time identity resolution capabilities are leveraged, right? The visitor scope stitches together multiple visits, potentially from different devices, into a single persistent customer profile using stable IDs, such as customer IDs or hashed emails, right? So this creates a comprehensive long-term view of a customer, right? And it contains valuable attributes like lifetime value, last purchase date, or cross-sessional behavior and cross-device behavioral tendencies. So this is a rich historical context, and it's the fuel required for sophisticated AI applications like predictive personalization, churn modeling, and customer lifetime value forecasting. Last but not least, we're going to talk about the audience scope. So this scope provides groupings of visitors who share common attributes or behaviors. So these are typically defined by segmentation rules based on the data from the event, visit, and visitor scopes. So you have all of those rich contextual attributes to use as building blocks to now define these logical groupings of visitors who meet the criteria. So what does this look like in a data flow? So here we're going to look at all three scopes, and we're going to start here with the events. So these events are flowing into the system, as you can see: page views, clicks, search, form fills. These could be any sort of events about any system though, right? It might be an IoT device, it might be an actual machine in manufacturing, right? Here we're focused on an individual visiting a digital property. So these events are going to build into sessions, visits. So as you can see, each of these different events and when they happen are around a specific session. So now we have not only the raw level of data, but we have the session level of data, and all of that is building into this visitor profile. So this visitor profile has the aggregation of everything. So this hierarchical structure is fundamental to enabling a wide range of AI outcomes. So it allows models to access data at the precise level of detail and context required, from the immediate atomic actions, right, of the events, to long-term holistic behavior patterns and segmented groups. So from here, we're going to jump into Telium functions. So Telium functions are our serverless environment. This is where we're going to actually perform the hashing of the potential PII. We're moving from the data itself to the logic that processes it now. So these functions are serverless compute environments embedded directly within the data processing pipeline, and it allows us to write custom code to execute at key stages, right? It's critical to differentiate between these three distinct function types that we're about to talk about and select the appropriate one when you're designing the system. So first and foremost, it's the data transformation function. This is the transformation. This is the function that we'll be using in this part one of the configuration today, right? It's got a limited time to live of 150 milliseconds per invocation, right? And the reason this is because it's at the beginning of a pipeline. The strict 150 millisecond execution limit, as well as the fact that it's cannot reach out to the internet, right? It ensures that it can perform its task without introducing unpredictable latency into this main phase of the data pipeline, right? And it makes it ideal tool for high-speed inline operations, right, that need to be applied to every single event, right, such as an initial validation, right, schema enforcement, right, in our case, this preliminary regular expression scan for potential PII. And this is where this is happening in the Telium data flow. So as we go from left to right, we're going from collection, right, and then right here in this green box, that's where the function is going to be triggered. So right when it hits the Telium system, before it's processed by any of the components in Telium, this is the first thing it will hit. So here we can perform our check for potential PII. Next, we're going to move into our other two types of functions. These are different functions as they operate at a different point in the pipeline. They operate at the end, which we'll see here shortly in a diagram. So in contrast to the transformation function, the event function, the visitor function are designed for tasks that might take a lot longer, right, than the 150 milliseconds. So we have a 10-second execution time, as well as support for making calls out for more complex logic, right? That where we can't block that primary data flow. So this might include use cases like calling an external ML or AI API for enrichment, write a recommendation. It might be synchronizing data with a third-party system, right? So all of this is important, and we need to make sure that we choose the right event or visitor function, right? And based on the required context that we need. So, right, the event function is only operating in a stateless way on that single event, right? So if we only, that's the amount of information we have, is that single payload. And we'll actually use the event function in part 2 of this to actually reach out to AWS Comprehend, right? And the visitor function, right, has access to the complete persisted visitor profile after all updates have been applied. So this happens at the end here. So you can see here after we've gone through, and either with that stateless event here flowing through the bottom, or at the very top here, the visitor profile, right? We have a function at the end that has a 10-second timeout to be able to utilize this. All right, so let's get into the configuration. We're gonna bring together all those preceding concepts, the data scopes, the serverless functions, right, into a single cohesive reference architecture for real-time PII detection. So let's pop over to the Telium interface. So this is the Telium Customer Data Hub. And you can see here we've defined a few different sources from traditional websites, streaming, over-the-top devices like Roku, as well as mobile apps. So we're going to hop into functions now here. And you can see I've already configured this one, but let's start off new. So first and foremost, as you can see, we're going to give it a name and a description. So this will be webinar PII detection. Detect potential PII. And right here we have our 3 different types of functions: processed event, process visitor. So once again, right, we'll just pop this up, happening at the end of this pipeline. What we're going to do here is data transformation, right? The beginning of the pipeline here, right? This has a shorter time to live, only 150 milliseconds, right? So let's hop into the one that we've created already. So the step that you'll go through is first to configure this initial check. When should this run? And right here, we're operating on the entire payload of data. And this is our logical operator here. We'll choose regular matches, regular expression. There's quite a few. And then we have our regular expression here. So this allows us, for every event that's coming in, to do a check on the entire payload of data to see if it matches this regular expression, right? Remember, this is just the cheaper initial check to ensure that we don't run the expensive check when we don't need to. So this allows us to take, and when this is met, we're now going to run this code. So in addition to code, we have monitoring, we have logs, and you can actually export these logs. One of the really great things is you have this fantastic environment here to write JavaScript in that's only triggered when this condition is met by the payload of data. And you also have a testing environment. So here, we're going to go ahead and say, all right, we have our payload of data, and we can go ahead and add a new key value to make sure this works. So here, right, maybe inform first name. Someone accidentally put that there. Now we can save this. So we can say webinar. And we'll save that. So now what we have here is we can go here, we can go webinar PII payload, and we have a nice testing environment here. So first and foremost, what's going to happen is this payload or the event sent in is going to be passed in here as the argument. We're then going to run our find and hash email keys. This is just a very simple way to find a specific key and hash it. We're using this crypto library here that we've imported into this environment. And you can see we're calling the hash function here. We'll log this out, but we'll also label this payload of data. So we want to label this payload of data for what will happen in part 2 where we want to take this, we want to isolate this payload of data, and then we want to actually do our more expensive check to AI or ML for verification. But we can actually take and run this test right now. So as you can see, this comes in and it actually runs, and we have logs of this obviously, but we can view this transformed event live. So we know we put it in here. You can see we have this potential PII detected key and value now added, as well as we've hashed this value. Now we could have kept that value also, but I've chosen just to overwrite it here. So today we've talked about part 1 of 2 in the configuration of a real-time PII detection pipeline that also meets the criteria for handling high volume, real-time streaming data, right, in a cost-effective and performant manner. In part 2 of this, we'll take what we're doing here, and we'll go into the next steps of isolating the payload and using a event function to be able to actually act on that piece of information that we've labeled and isolated, or that payload that we've labeled and isolated, to verify our setup. Thank you for attending part 1 of this webinar, and we look forward to seeing you in part 2.